Okay, let's look at solving some more advanced problems using the skills that you learned in your previous video. So there you simply learned how to use your calculator to find your pH or your pOH or whatever you were asked for. So let's look at a problem that has a few more steps. So now we want to know the pH if we add 10 grams of sodium hydroxide to enough water to make 100 milliliters of solution. So first we're going to have to calculate the molarity of that hydroxide and then the pH. So let's look at the steps we're going to need. In order to get the molarity, remember your molarity is your moles over your liters. So you're going to take your 10 grams of your sodium hydroxide and using the molar mass, you're going to get the moles of sodium hydroxide. So take your 10 divided by your 40, and you're going to get 0.25 moles of sodium hydroxide, 0.25 moles. But you need a molarity. So you need to divide by your volume, and your volume needs to be in liters. In order to turn 100 milliliters into liters, simply divide by 1,000 or move that decimal over 2 places, and you've got 0.1 liters. Now take your 0.25 divided by, clear that, 0.25 divided by your 0.1, and you get a 2.5 molar solution of sodium hydroxide. Okay, so to find the pH, we first have to take the negative log of this number to give us the pOH. So if we take the negative log of our 2.5 molar, we're going to get a negative pOH, which does look unusual, so let's round it let's put it at negative 0.40, okay? Negative 0.40. You may not have been aware that you can have negative pHs and negative pOHs, so let's stop for a second and let's look. Okay, so if you had a 1 molar solution of acid, let's say you had a 1 molar solution of hydrochloric acid, so if you negative log that 1 for your 1 molar, you'd have a pH of 0. Let's say you had a 1.5 molar solution. Negative log of 1.5 gives you a negative close to 0.2. So you can go outside of that pH range. 6 molar solution, a negative log of 6 gives you a negative 7.8 pH. So you absolutely can go above and beyond that. We want the pH of the solution, and right now we have the pOH. So we need to say 14 minus the negative 0.4. Okay, slide that over. So 14 minus a negative 0.4 gives us a 14.4 pH, which is slightly above what you think is the high end of pH. The normal scale goes from 0 to 14, but you certainly can go over that. Okay, so you have a pretty concentrated sodium hydroxide solution, so it is highly basic. So first you had to get your moles, then divide by your volume in liters to get your molarity, then take the negative log of that, which is still not the pH. This is a base hydroxide, that's the pOH, and then subtract from 14 to get your pH. Okay, so let's look at the second question. The student dilutes the original solution prepared above to a final volume of 1,000 milliliters. Calculate the new molarity and the new pH. So this is using your dilution equation along with your pH and pOH. So their original molarity was 2.5 molar, and we had 100 milliliters of it. I'm going to go ahead and keep my numbers in milliliters with the dilution. As long as your units are the same, I'm going to I'm going to use the milliliter unit here. Then I'm going to set this equal to finding the new molarity when I dilute it to 1,000 milliliters. So if I take my 2.5 times my 100 divided by 1,000, I'm going to get a 0.25 molar solution. You probably could figure that out. You're diluting twofold. So 0.25 molar sodium hydroxide. If I take the negative log of that, so negative log of my 0.25, I'm going to get a pOH of 0.60, we'll round it to that, and 14 minus that gives me a pH of 13.40. So as I diluted my solution, I became less basic. Notice by 1 pH unit. So 100-fold, okay, I had going from 100 milliliters to 1,000 milliliters. So look, that's a 0.1 or a 10-fold dilution changed my pH by 1 unit. So for every 10-fold dilution, you will change your pH by 1 unit. Let's look at a hydrochloric acid solution. So a student prepares 500 milliliters of an HCl solution that contains 0.2 moles. They then dilute it to 2 liters. What's the pH? So let's go through this systematically. So you've got 500 milliliters with 0.2 moles. So let's figure out the initial molarity. So 0.2 moles over 0.5 liters. Remember, you have to be in liters for molarity. 0.2 divided by 0.5 gives you a 0.4 molar hydrochloric acid solution. Okay. If you took the pH of that, let's just do that, negative log of 0.4 would give us a pH of less than 1, about 0.4. Okay, that's a pretty concentrated solution. So now they want us to dilute this solution to 2,000 milliliters or 2 liters. So here's our original solution, and we had 500 milliliters of that, and we're going to dilute it to 2 liters, so we're going to write that as 2,000. You could have kept this as 0.5 and 2, doesn't really matter. Usually when you're in the lab, you are measuring in milliliters. So we want to know the new molarity if we dilute to 2,000 milliliters. Okay, so slide that up. Clear, we've got 0.4 times 500 divided by our 2,000 gives us a 0.1 molar solution. And if we negative log that, so negative log that number, negative log of 0.1 is going to give us a pH equal to 1. So these are some problems that you would encounter in the laboratory by making solutions and then diluting them or figuring out what the pH is of the solution that you've made. Of course, you can stick a pH meter or pH test paper in that as well and compare with your calculated values. So these are slightly more advanced. They are combining your molarity skill with your pH skill, also with what you are understanding that you are finding. So when you did your other worksheet with just punching numbers in, were you really understanding what you were finding if we call that hydrochloric acid and sodium hydroxide instead of just H plus and OH minus? So I will make this a little smaller and leave this up here for you to look at So this would be the high end of where I would want you to be able to go with these calculations. We will spend more time on these in the week after this week, but this gives you a peek at that. And if you're good at this, then you know that you're not going to struggle much with these concepts.